So here we're going to look at the actual double replacement reaction. So I've got all my chemicals here. When we do it in the lab, we just do 1 or 2 drops of each. But right here, I'm going to use a test tube. So right there, that is silver nitrate, clear, colorless liquid. And this is sodium phosphate. So both of these are clear, both of these are colorless, and if I do a couple drops, I see a little bit of precipitate, or when I mix a lot, I see a lot of cloudiness. We can kind of see down there in the bottom, a little bit of motion even, but we see a solid formed. So we know that one of our two products is a solid, and we use the solubility rules to determine that. My second set is lead nitrate and sodium sulfate. Same idea. We've got two clear, two colorless liquids. When we mix them together, we can see an obvious color and texture change. So we see very cloudy. This one's almost milky, but a really thick liquid now, or a liquid that's got a bunch of solid precipitate in there. Here, iron is a little bit orange, and then my sodium carbonate is still clear and colorless. When we mix these, there we can really see kind of at the bottom some interesting look to that and some texture. But we formed a solid. We double replaced. This time the color was there to begin with, and it's still there at the end, but we have a very different texture where we formed a solid. So this is what we were looking at: was what did they look like before? Most of them colorless, although iron had a little bit of color, and all of them clear. And then at the end, we saw color, and we started to see some texture or some cloudiness in there. We saw some cloudiness for sure in there. Right there, we're even forming a bunch of chunky solid at the bottom. And a similar idea here, the solid is weird enough looking that we can actually see it, and it gets almost stuck in the middle of our test tube. So we've got some great observations there of our reactions.